Hello everyone, my name is Aram Ortiz. I will be presenting improving materials in biomechatronic prostheses that assist to incapacitated people. Including this presentation, I will talk about biomechatronic field in mechanical engineering, which will include mechanical engineering in the field of prosthesis and prosthesis design. I will also talk about prosthesis problems, which topic will include most common issues related problems to prosthesis and the development of prosthesis. The following topic that I will be talking about is prosthesis, which will include the island quantum prosthesis and the definition of biomechatronics. The next topic that I will be talking about will be new prosthesis linking concept, which will be followed by materials as important factors in the performance of prosthesis. Electroactive polymers will be the next topic, and it will be followed by a video that is being called the electroactive polymer artificial muscle spring load actuator, which is a video presented by Hisok. The next topic that I will be talking about is electroactive polymers and the references that I has been using in my presentation. Mechanical engineering in the field of prosthesis is a field that involves the study of mechanical systems, one of which is the prosthesis for human's body. By generations, many people have had to use prosthesis to replace a body part. This prosthesis has been developed in many ways that has helped humans in many ways. The prosthesis designed by generations, people have had to use prosthesis to replace a body part. Its elements and components makes prosthesis an interrelated system that has been constantly improving. This is why it is important to design a dedicated system to overcome the patient's needs. Prosthesis problems. Most common issues related to prosthesis involves poor fitment, sweating problems, weight problems, and energy consumption to move. These problems features the needs of prosthesis development. Most people who need a prosthesis doesn't have the physical ability to deal with prosthesis problems. Development. Companies like Touch Bionics, Strapper, Autobox, and many others develops arms for people who have an incapacity. Prostheses. Prostheses are a constant evolutionary invention. The Egyptians were pioneers in the elaboration of these artifacts, said Para. The material by which these artifacts are made is one of the most critical points on the utility and the effectiveness of these prostheses. Many materials have been used to improve these factors, which in the case has been applied in the development of biomechatronic prostheses. The alien quantum. As an example of the development in this field, we can take a nowadays arm replacement for humans. Alien quantum, developed by Touch Bionics, has been developed to the needs of many users, even having different sizes of hands. In their website, touchbionics.com, the specs of limb can be found, which is the following: Four methods of controlling for ultimate freedom. Faster with speed boost feature. Indeed, speed can be increased by up to 30%. Stronger than previously designed prostheses with 30% more power when required. Extended battery life. Electronically rotating thumb automatically switches between lateral and oppositional grip patterns. Select from up to 36 different grips available, both pre-programmed and customized. Varied grip mode allows variable digit-by-digit grip strength. Auto grasp feature to prevent objects from slipping. Industry unique touchcare package offers unparalleled warranty support for up to 5 years. This information has been found in the Touch Bionics Incorporation website. Defining biomechatronics. Biomechatronics is the merging of a man with a machine. It is an interdisciplinary field encompassing biology, neuroscience, mechanics, electronics, and robotics. Biomechatronics scientists attempt to make devices that interact with human muscle, skeleton, and nervous system with the goals of assisting or enhancing human motor control that can be lost or impaired by trauma, disease, or birth defects. This definition was made by Frederick and Bernstein, which can be found in my references slide at the end. New prosthesis linking concept. The new generation of prostheses can be designed to be linked with the brain to the nervous system, which allows the patient to fully control the prosthesis, instead of using an app in the cell phone like most current prostheses. Reliable communication between the prosthesis and the body has been the missing link for the clinical implementation of neural control and sensory feedback, and this is now in place, said Catalan, which I will also include in my references slide at the end. Materials as important factor in performance. The biomechatronic prostheses use most efficient materials. Among these are included the electroactive polymers and lightweight reliable materials. The material used will have a direct effect in these innovative inventions. Biomechatronic prostheses. Commonly used materials will make a prosthesis heavy, impractical to operate, corrosive, among other negative factors. The biomechatronic prostheses use most efficient materials. Among these are included electroactive polymers as example. These polymers are being studied to be developed as artificial muscle. Improving prostheses. The material by which prostheses are made is one of the most important parts on its utility and effectiveness. An example of these are electroactive polymers, which improve human motion interface between the human and the surroundings. Electroactive polymers. Electroactive polymers can be used as muscle replacements. The advantage gained by these polymers, named electroactive polymers, which is abbreviated as EAP, are widely given. Its application is inside the human's body to restore a normal function. In the picture can be seen a concept of the electroactive polymer configuration will respond to electric current. In this picture we can see as in the top view there is the initial EAP configuration. Afterwards we can see in the lower picture how it will respond if electric current should be used to make it function. In comparison, we can see the before and the after. Electroactive polymer artificial muscle EPAM spring roll actuator. Video presented by Heathrow. In the video can be seen how artificial muscles respond to different signals. These signals can be taken from the human body if they appear to be designed in a muscle replacement or the design of artificial prosthesis. Here in the video we can see how this cable over here is linked to which will be representing the muscle, which in the case comes to be this part over here, which is the electroactive polymer. Uh, this electroactive polymer can be represented as the muscle that can be a substitute to a loosened muscle to a human by an accident or by birth, which is meant to represent the new concept of the new prosthesis. Defining furthermore, these electroactive polymers are an innovation that takes out the conventional gears and plastic steel components that are to make a mechanical system. The development of EAP can lead to preventing the amputation of a body part due to missing or failure muscle. The case can come to compare current prostheses with these brain-controlled prostheses or artificial muscles. The controlling features of the current prostheses use, for example, apps in the cell phone or previously programmed commands. Instead of these features can be taken into a more realistic way by designing a neurotransmission sensitive prosthesis. Also, the electroactive polymer materials can replace muscles when they are lost or atrophied for some accident, which in the end can result to even prevent amputation, discarding the need of a prosthesis in many cases, which in the end may lead us to comparing the current prosthesis in the market to help patients to these new innovative prostheses. On our daily lives, we can see many people who have lost an arm, a leg, or maybe a knee. There are many companies that have many products with many ideas and many concepts. Many of these processes have some fingers or a foot on the end of the arm. Some of these processes doesn't have them, but the new idea of designing these biomechatronics um, processes is a new concept that joins three main fields, which involves the biology, which is medicine field that studies how the neural part of the human body works. So you can have a neurotransmission signal coming from the brain to be taken by the prosthesis, which comes to the electric engineering field that uses that signal that came from the brain to make us a message that is being developed to the mechanical engineering design that uses that signal to help the patient interact with the environment. So if a patient wants to grab a cup of coffee or a glass of water, that patient can grab it because he have or she have an entire design system that is meant to develop this signal into an interaction with the environment. So here at the end I'm holding my references, which is where I found every single information that I presented here in this presentation. And thanks for watching and your time.